What is meant by an adsorption isotherm? You are familiar with the term isothermal. Isothermal means constant temperature. So adsorption isotherm means adsorption studied at constant temperature. What is an adsorption isotherm? It is a curve which is obtained graphically by taking pressure along the x-axis and the amount of the gas adsorbed by the adsorbent, that is x by m, along the y-axis at constant temperature. The curve thus obtained is known as or named as adsorption isotherm. Freundlich gave a relationship between the amount of the gas adsorbed by unit mass of the adsorbent and pressure at a particular temperature. This is expressed as x by m is equal to k into p raised to 1 by n. This expression is known as Freundlich adsorption isotherm. In this figure, you will find three different adsorption isotherms studied at three different temperatures, one at 273 Kelvin, another at 244 Kelvin, and the third one at 195 Kelvin. See, the variation in the amount of the gas adsorbed by the adsorbent with pressure is studied at a constant temperature of 273 Kelvin. Similarly, the next variation is studied at a constant temperature of 244 Kelvin, and the third one is being studied at a constant temperature of 195 Kelvin. Each curve shows a variation in the amount of the gas adsorbed with pressure at constant temperature. Consider Freundlich adsorption isotherm. The expression is x by m is equal to kp raised to 1 by n. Now take log on both sides of this equation. Then it becomes log x by m is equal to log k plus 1 by n log p. This equation is now of the form y is equal to mx plus c. And you know that this equation represents a straight line. So if we plot a graph taking log x by m along the y-axis and log p along the x-axis, we will get a straight line with a slope equal to 1 by n. And the slope will be positive. The intercept gives you log k. Adsorption from solution phase. Adsorption can take place in a solution. You know that a solution is made up of a solute and a solvent. For example, consider a solution of acetic acid in water. Here, the solute is acetic acid and the solvent is water. To such a solution of acetic acid, let charcoal be added. On adding charcoal to a solution of acetic acid, it is found that due to the adsorption of acetic acid by charcoal, there is a decrease in the concentration of the solution. Now coming to the various factors affecting the rate of adsorption in solution. The extent of adsorption is found to decrease with increase in temperature. This is again because adsorption is an exothermic process. Another factor which affects the rate of adsorption in solution is it increases with increase in the surface area of the adsorbent. It also depends on the concentration of the solute in solution. The extent of adsorption is found to depend on the nature of the adsorbent and the adsorbate. You remember the Freundlich adsorption isotherm expression in which we have x by m is equal to k p raised to 1 by n, where p is pressure. Now the same equation can be applied in the case of solution, but here the pressure term will be replaced by concentration. So we get the equation or expression as x by m is equal to k c raised to 1 by n, where c is the concentration of the solution.